Hello students, we were studying the chapter motion in a plane, where theory part we have done, many bits of theory part is covered. A few numerical problems also I have taken. This is a very good numerical problem. I would like to take this on the board. See, I and j are two unit vectors along x and y axis respectively. What is the magnitude and direction of vectors I plus j and I minus j? There are two parts. First part is this, so we will start solution. Let these two vectors are. This vector I plus j is, suppose it is b vector. B is equal to I plus j vector. So we will talk about magnitude and direction of this vector. About magnitude, we already know that. I'll tell you, suppose a vector p is there and it is xi plus yj, then the magnitude of this vector p, that is simply capital P write, or it is mod of vector this is equal to under root x square plus y square. And what about the direction? Direction is given by tan theta, that is equal to y by x. And what is this? Theta. Theta is the angle made by the vector with x-axis. So considering this standard formula, we can find the magnitude and direction of this vector b. So about magnitude, this is b is the magnitude or mod of vector b, that is equal to under root 1 square plus 1 square, because in place of x is 1, in place of y is 1, after comparing with this vector. So that is equal to under root 2 is the magnitude of this vector b. About direction, tan theta 1, suppose. We are having another vector also. Suppose it is theta 1. Theta 1 is the angle made by this vector with x-axis. So tan theta 1 is equal to, according to definition, y by x, that is 1 by 1, that is equal to 1. And tan theta 1 is equal to 1. This implies tan 45 degree. Therefore, direction theta 1 is equal to 45 degree. Okay. Now, we will talk about another vector, that is I minus j. Let this vector C, that is I minus j vector. We will find the magnitude of this vector. So magnitude is C, that is mod of vector C, that is equal to under root 1 square plus minus 1 square, because y is minus 1 over here, isn't it? So that is equal to 1 plus 1, that is equal to under root. Magnitude of this vector is also under root 2. What about direction? Suppose it makes an angle theta 2 with x-axis, then it will be minus 1 by 1, that is equal to minus 1. It is minus 1 means it is tan minus 45 degree. Therefore, theta is equal to minus 45 degree. So what is the significance of plus 45 degree and minus 45 degree? That too should be understood. So see, measurement, this is the baseline. If the angle is subtended by turning this line in anti-clockwise there, then it is taken at positive, and then by turning it in clockwise direction, then it is negative. So for 45 degrees, suppose, so this direction I have taken this way, right? This is plus 45 degree. If you are coming clockwise, this is minus 45 degree. And this is suppose baseline. So this thing should be clear. Turning this way, x, suppose y, then this angle is positive, this angle is negative. So according to this, these vectors can be represented like this. Suppose this is the reference axis I have drawn. So this is the vector b. This is the vector b, I plus j. It is 45 degree from baseline, and here minus 45 degree, this is the vector c, that is I minus j vector. So magnitude and direction of these two vectors are clear. Now we will talk about the unit vector of b. So this concept is clear. B is in this direction and c is in this direction, and both are making 45 degree, one in positive direction, another is in negative direction. So first part is over. Now we will look at the second part of this question. Now next part of this question is, what are the components of vector A along the direction of I plus j, I minus j? So the vector A is 2I plus 3j. So we can find the magnitude of this. Therefore, magnitude A, that is equal to mod of the vector A, is equal to under root 2 square plus 3 square, that is equal to under root 30. And what is direction? Tan theta 3 we consider, that is equal to 3 by 2 y by x. Now 3 by 2 means it is 1.5. Tan 45 is 1 and it is 1.5, means the direction of this vector A will be something like this. This will be the vector A. This is the origin. Now we have to find the component of A on this and component of this on this. So first we will consider the component of the vector A on B vector, right? So angle between A and B, if we consider it is theta, then suppose this is the vector B, this is the vector B, and this is the vector A, and this angle is theta. Now here theta is to be found out. Before going for this is 45, and from here to here this angle is what? It is theta 3. It is theta 3, and this angle is theta 2. Theta 2 means is equal to 45 degree. So what is theta? Theta is equal to theta 3 minus theta 2. In fact, it is theta 1. This is theta 1. So theta 3 minus theta 1, that is theta. Therefore, tan theta is equal to tan theta 3 minus theta 1, that is equal to tan theta 3 minus tan theta 1 upon 1 plus tan theta 3 tan theta 1. Now we will put the values. Tan theta 3 is 3 by 2 minus, for this angle, if you remember, tan theta 1 was equal to 1 because theta 1 is 45. So tan theta 1 is 1 upon 1 plus 3 by 2 into 1. 3 by 2 minus 1, that is 1 upon 2. 1 plus 3 by 2 is 5 by 2. So this will go, we will get 1 by 5. Therefore, tan theta is equal to 1 by 5. This we got, right? So from this, if you look at what do we need? If you draw perpendicular on this B, this is the vector A, this is O, this is P, and this is Q. So OP, length, is the component of magnitude of A, right? If A vector resolved in two perpendicular directions, so this is one vector, this is another vector, so OP plus QP is equal to OP. So component of this along B is the vector OP. So we want vector OP. So component of the vector A in the direction of B is vector OQ. So this is important. We want OQ vector. So before that we will have to find the magnitude of OQ and the unit vector along B. Right? So we know what is the vector B? Vector B is this. Therefore, unit vector along B is equal to B cap, and that is equal to how much? This vector B divided by magnitude of vector B, that is magnitude we found, that is 1 upon under root 2. So the magnitude of this vector is under root 2. So we will write I plus j upon under root 2. This is the unit vector along B, means along OQ. Now what is required? This length OQ is needed. That we will look at. So this unit vector along B is known. So OQ is equal to OP cos theta. OP is known. Magnitude of A cos theta we found over here. Tan theta is equal to 1 by 5. If this right angle triangle, this is the right angle triangle, then 1 by 5 is tan theta. This will become under 26. So cos theta is equal to 5 upon under root 26. We have put the value and we got OQ is equal to 5 upon under root 2. Magnitude is known. Of course, it is the magnitude of component of A along B. And the unit vector along B is this. Product of these two gives the component of vector A along B. From here, C is equal to I minus J. Then what is the unit vector of C? So unit vector of C is C cap. C cap is equal to C vector upon mod of C vector. Right? So C vector is I minus J. Mod of C is under root 2. So unit vector along C is known. And we have to find the magnitude of component of A along C. So we will draw a separate figure for that. You see, angle between A and C is more than 90 degree because this is 45, this is also 45. Total angle between B and C is 90 degree and plus theta. It is more than 90 degree. Suppose this is C vector, then A vector have direction something like this. It should be more than 90 degree. If it is 90, it is more than 90 and this is theta. Total angle from here to here, it is 90 degree plus theta. So if you want component of A along this line, so we will have to extend this line and drop the perpendicular. This is O, this is P1, this is Q1. So OA vector, when it is resolved, so one component will be in this direction, another component will be in this direction. So we want vector OQ1. So before that, we want to find the magnitude, length of this vector, right? I mean, in this triangle, we will find the length OQ1. So you see, this is mod of A, that is equal to under root 13, this one, and this is 90 plus theta. So how much will be this angle? The total is 180 degree. So this angle will be 90 degree minus theta. Then only sum of these two will be 180. Theta and theta will go. We will get 90 plus 90, 180. It is 90 minus theta, so this angle will be theta. So we will find the value of OQ1. So OQ1 is equal to OP1 sin theta, right? Now OQ is equal to OP1 sin theta, and OP1 is known, that is under root 13 sin theta. Now sin theta we have to find out, and tan theta we know, we have seen tan theta was 1 by 5. If it is theta, it is under root 26. So sin theta is equal to 1 upon under root 26. So that is equal to under root 13 into 1 upon under root 26. That is equal to 1 upon under root 2. So this is the length OQ1. So magnitude of the component vector of A, component vector, that is OQ1 of A along C vector, that is OQ1, that is equal to 1 upon under root 2. This magnitude is known. Unit vector along this is known. So unit vector opposite to this, because direction actually is this, OQ1. It is in this direction. OQ1 is the opposite of this. So we will take negative of that, negative of C, unit vector. So therefore OQ1 vector, that is equal to, magnitude is 1 upon under root 2 multiplied by negative of C, because unit vector is in this direction. Actually the direction of the component is along this. So we will take negative of C unit vector, that is minus C unit vector, that is equal to 1 upon under root 2. Minus of C is minus of I minus j upon under root 2. So that is equal to, minus will be taken out, so minus 1 upon 2 I minus j. This is the answer. This way we have found the components of the vector A along this vector and this vector. So this is the answer. Question is big. It appears as if it is very cumbersome and complicated, but we have used the fundamental concept behind the vectors and we solve the problems. Revise once again, see every line, every bit of the things, then you will realize you have got many things applied in this question. So wish you all the best. Take care.